Okay, then. Thank you, Magesh, for the opportunity to present here. Hello, everyone. I am Sukanya, and today I'll be presenting our work on BurnoutWords, detecting burnout for a clinical setting. This paper was written by me and Professor Dr. Mascha Kurpicz-Briki from the Institute for Data Applications and Security at the Bern University of Applied Sciences in Switzerland. So before I introduce the work that we have done on burnout, I'd like to briefly describe a bit of the background of the problem. We have all probably felt professional stress at some point of time in our life. So the word burnout is quite fairly frequently discussed nowadays. So a little bit of stress is understandable, but sometimes the stress reaches up to a chronic level, which interferes with our well-being, which even prevents us from doing our work properly. WHO uses 3 dimensions to identify such chronic stress levels. The first is a feeling of deep exhaustion or depletion of energy. The second dimension is a feeling of distance from the work, certain amount of negativism, not wanting to engage in one's daily work. And the third is feeling a sense of emptiness or ineffectiveness. So these are the 3 dimensions that we use currently to identify burnout. There have been many definitions, but we decided to stick with the WHO definition here. So we've heard a lot about burnout, about how common is it really. The American Psychological Association, during the pandemic, they have done a survey and they found that in Americans, about 8 out of 10 Americans said that the coronavirus pandemic is a significant source of stress in their lives. So it is, even last year, actually, WHO has included burnout as a syndrome in its list of diseases. And we can say that it's an important problem because it's rarely, it's rather common at workplace nowadays. So what's our goal with this paper and our project is to identify burnout or to help people before we reach this chronic level of stress, so that we can already do some preventive measures, we can do some sort of intervention so that they don't end up being burnout patients. The second thing that we wanted to target was to use text data, because in general, when we talk about burnout or any other mental health disorder, there has been a lot of work done with questionnaires, surveys, but sometimes there are problems. I will discuss that in a moment with surveys. But sometimes the people talk informally or even in a doctor's office or with experts. And we think that this kind of text data we can use some natural language processing techniques, and we can give some sort of a pre-screening tool. The idea here is not at all to replace health professionals, but to give them some sort of a complementary tool that they can use to screen for possibility of burnout in the future. So what are the challenges that we face when we try to tackle this problem? The first is that it's a complex problem because there is a lot of overlap between burnout and other forms of mental health problems. For example, we talked about fatigue used as a measure of burnout. Now, fatigue is also exists in other mental health problems, for example, depression. So it's difficult to isolate burnout from other mental health problems. The second thing, as I mentioned, surveys before or self-test inventories. Now, it has been found that people either tend to exaggerate their problems or underestimate their problems. So there is a question of reliability. There has been often raised with self-test inventories. Another method that we wanted to use, the classical way to do that is to have an interview between a possible patient and an expert or a doctor. It's a manual process. which means that there is a large amount of overhead. You have to talk to the person, you have to note down, you have to transcribe, to interpret by the experts. And this is the proper approach, but we want to help in some sort of automation. So maybe it's possible to do it automatically to get some sort of a pre-screening idea. Since we wanted to identify burnout from text data, we looked for data sets that are available, and we were surprised to see that there are not too many burnout data sets available, not even in English. And we were looking for, since we are based in Switzerland, we have different languages here, it was even harder to find data sets in more regional languages here. So these were the challenges. So what did we do? We started to we started to use a set of interview extracts, which was the conversation between burnout patients and their doctors or experts. And these interviews were in German, which was also a plus point, because then we could use a regional language here. The idea here is that based on the conversation, in certain conversations, they were talking about their burnout experiences, but also other conversations were in general about other topics. So we could label the data sets in such a way that we could identify, okay, this text is related to burnout. Here the person is speaking about their experience with burnout, and no burnout text, in which case it could be any other general topic. So we could create two different classes based on this sort of labeling. The second thing we did was to extract features, textual features, from the wording of these burnout patients. And then we used a classifier on machine learning to then identify the burnout cases more specifically. So here is an example from the data set. I shall read the translation in English for all of us. It says, the doctor made the diagnosis. The doctor is a good colleague of mine and takes a lot of time for me. I only realized it approximately 2 months later. It needs time until one can accept it. I informed myself about the disease. The information on the internet did not help me. The doctor could give me advice. So we can see that this small text is actually about the burnout experience. Here the person is talking about how they felt about the diagnosis, how they're accepting it, etc., etc. So we could label this data as a being related to burnout, or as the burnout class. So our pipeline was rather straightforward. We had a bunch of text data, we call it, or the training data, which we fed as inputs. Each text was then tokenized to break it down into a series of tokens. And we counted the frequency of these tokens. So because we had rather small data set and small amount of text per instance, we decided not to take all the features, but rather take top features. So that was our filtration process. We had a strategy to select the top features. And then those features were fed into a group of support vector machine models, which we'll see in a moment. And that's how we classified our data. So as I was talking about features, so we can have a lot of features, but we wanted to we wanted to observe how the number of features influence the performance, which means that we have to select. How do we select the best features? So one way to select the best features was to observe those features which cause the maximum distance between the two classes. So we had two classes, burnout and no burnout, and we wanted to select those features which maximize the separation between these two classes. For here, we select, I shared the list of 10 such words with the maximum positive difference, and the translations in English, you can see there are even common words like and, things, one time, you, partially, to say. Medical practice there. You can see that some of these words are not really related to burnout. They're just commonly used function words even, but they help us in our classification. Similarly, we also have words which had a large negative difference between these two classes, which are also, we can see these words are like so, thus, work, patience, people, company, no, something, anything, okay, I, and so on. So some of these words we can see could be related to workplace, like company, work, or even patients, because we were talking about in the context of a medical diagnosis, and so on. So here we just made a small word cloud from the top 10 nouns that we extracted from the class Burnout. And we see that the top word is actually example. And I think just because the patients might have been talking, for example, these kind of words might have been used more frequently in the text, and so on. But we also see boss, we see appointment, deadlines. So it's interesting because you can already see that these nouns are rather related to their work life experiences. Okay. From the no burnout, on the other hand, we see a different type of things. We do see general words like, which could be related to profession even, like capability, competence, better, radiology, car. But this is just for our understanding how the words might differ between the classes. Okay. So we used SVM, support vector machines, as our models. This was actually a pilot study, so it was the first of the work that was done in this project. So in this case, we just decided to go with support vector machines because they are a very well understood and classifier, and they have also been shown to be very effective, particularly because we had a rather small data set. So I just briefly introduce what support vector machines are. In support vector machines, we have a hyperplane which tries to orient itself so that we can get separation between as many classes as we have. In this case, we had 2 classes. And there are a set of points from each class which help us to orient this plane. So these are known as the support vectors. Sometimes it's easy to see the separation in a linear plane, as we see in the example here. But sometimes, depending on how the boundary between the classes exist, we could use a different type of kernels. So these are like mathematical functions which transform the data into a different dimension. And sometimes it is easier to find a hyperplane in a different dimension. So we have different kernels like radial basis functions, sigmoids, or polynomials. We used these 4 types of models. So in our evaluation, you can actually first notice the random baseline here. So we had a rather unbalanced data set. We had about 73% of the data points belonged to the class Burnout, and about 27% belonged to no Burnout. So it was not a balanced data set. So when we used the SVMs, we found that, for example, the linear kernel was almost on the random baseline. So it's definitely not a linearly separable data set. But there were other kernels, such as the sigmoid kernel, which increased as the performance increased as we increased the feature set size. Okay, so with sigmoid kernel, we reached almost up to 80%, which shows that we are much better than the random baseline. Of course, it's not a balanced data set, so there is a possibility that with a larger data set, we could get even better results. So this is a confusion matrix of the sigmoid kernel SVM machine that we used. And we can see that we could identify that the model has a tendency to predict more burnout cases than no burnout. But that's also because the data was more in favor of burnout classes than no burnout. But that's the confusion matrix. Yes. So in conclusion, we introduced a burnout dataset in the German language that was based on text data. We showed how we can use NLP to identify burnout. Um, um, of course, this was, like I said, it was a pilot study. So since then, we are trying to create more varied kind of data sets. We are working on even social media data, how we can identify burnout from social media data, or even based on questionnaires of our own. So these are things that are still continuing in this project, and more work is planned in the future. So that's from my side, and I'd like to invite questions now.